Hello there, welcome back. So today we have another video which explains about one of the services of AWS, which is nothing but VPC. VPC stands for Virtual Private Cloud. So what a Virtual Private Cloud stands for is like AWS as such is a cloud service provider, right? You are going to run all your VMs there, virtual machines, or your database, or your serverless computing over there. What we are additionally trying to do is carve out a small portion of that AWS, the cloud, and containerize it so that you can put all your stuff inside the container. So if you see this violet color box over here, that's going to be called as your VPC, which is your virtual private cloud, right? Inside which we are going to have our subnets, we are going to have our VMs, we are going to have our security group, we are going to have routing, we are going to have our own NACL, we are going to have choose an internet gateway. So if all that sounds confusing, let me break it down individually, okay, one by one for you. So VPC, you could consider it as one of your data centers. Your data center would have a network range, right? So our data center in the cloud is going to have a range of 10.0.0.0/16. All right. So underneath that, we can subdivide this particular big chunk of IP ranges into several sub chunks of IP range, right? So I have created two such IP chunks. Okay, one is 10.0.1.0/24. So this can host about 255 IP addresses, and 10.0.11.0/24. This again can host about 255 IP addresses. But in effect, we would get little bit lesser than that because AWS would reserve 3 IP addresses, one for gateway, one for DNS, and one is reserved, if I'm not wrong. So, um, these two subnets, right? I'm going to classify one subnet as my public subnet, which is the missions on this subnet would be able to reach out to internet, and another one as private subnet. So the missions on this subnet will never be able to go out to the internet. Rather, it would need some kind of a special mechanism via which it can go out to internet. Like the special mechanism could either be an NAT instance, which will put here and ask the private mission to go out to the NAT instance to go out, or we would either use something called NAT gateway, which is wholly Amazon managed service to go out to the internet. Okay, let's start breaking all these things further down. So first we saw the subnets. One subnet can reside only in one availability zone. That's a given. Okay, you can't have the same subnet present in availability zone 1 as well as availability zone 2. So that mapping is done. Right now, let's go over to something called as security group, which is nothing but local firewall for an instance. So if we are creating an instance here, and we are going to associate that particular security group to that instance, that becomes its local firewall as such. Okay, then that's the same case with this particular instance over here as well. We have to associate a particular security group over to that particular instance. All right. Next, let's jump all the way over here. So here we have the internet, which is outside the AWS cloud. We have another cloud called internet where we belong to, right? So in this cloud, so if the missions on this in this VPC were to go out to internet, or the internet were to go into this particular VPC, it would work only with the help of internet gateway, as the name suggests, right? Internet gateway. If I have to go out to internet, I use this particular gateway, and there is a one-to-one mapping between an internet gateway and a virtual private cloud. Okay, there could be only one. If this internet gateway is associated with this VPC, it cannot be associated with a different one. Likewise, one VPC can have only one internet gateway. Okay, that is also done, right? Public, the subnet mapping to one AZ and VPC mapping to one internet gateway is done. Now, for a VPC, we can have a network access control list, right? So what this network access control list does is, it will additionally, it will by default apply to all the missions in this particular VPC, right? And it is moreover stateless. What does stateless mean is, in the case is that if a mission over here were to browse google.com, right? what would be the destination port which this mission tries to access? It would be port 80 of google.com, right, or port 43 if it were to be secure. So while going out, I have to say port 80 is allowed, right? Then it would go out. When it is returning, what would have been the source port when it went out? It would be some ephemeral port, right? Something from 1024 to 65535 ports. It could be any one of that. So when this google.com server is replying to that, it will reply to one of those ephemeral ports. Okay, so that is where this particular rule would match. Okay, port 80 wouldn't match here because that's an inbound rule. So port 80 would have matched when it goes out, right? It will fall under the outbound rule where I say allow all ports. It will match that and it will go out. The return traffic will match the inbound rule of 1024 to 65,000 K ports, right? Then it will get inside. That's one. Then security group which are applied to each and every instances are stateful. That is, when a mission tries to go out, the return traffic will automatically get matched. Then we are almost covered here. The only thing which we have not covered is the route table, right? So what route table does is it will create, so by default when you create a VPC, it would create a security group, it would create a NAT gateway, it would create a route, right? This route which it creates by default would enable us to route traffic between the subnet range which is specified in the VPC. Okay, however, it will not the default route might allow if a default internet gateway is present, but if we were to create a route table separately, that wouldn't allow the internet bound traffic. So what we'll do is we create a route and specify that we have to attach two things to it. One is the internet gateway, that is all traffics going to 0.0.0.0, that is anywhere, would have to use internet gateway to reach out to internet, is what one leg of it specifies. The other leg of the route table would specify that which subnet is going to be allowed to use that particular route, which is going to be this public subnet over here. All right. So now this public subnet can go out to internet via that particular route. So this is exactly what we are going to accomplish now. So if I open up my AWS, I click on services and clicked on VPC. Over here, network and content delivery, clicked on VPC. I ended up on that screen. So if we go back to dashboard, by default, Amazon would create us one VPC, one route table, one security group, internet gateway, 6 subnets because Northern Virginia has 6 availability zones and one network ACL. But what we are going to do is we can use the wizard to set up a VPC, but we are going to do this manually so that we get better understanding of this. So your VPC, let's create a VPC. Okay, let's stick on with the same name of Bala VPC, right? And the CIDR block is going to be 10.0.0.0. Oh, there's one more zero there, right? /16 and say yes, create. So the tenancy is going to be default tenancy, that is anyone can occupy in the same stack on which my cloud is residing. So that now that I have created that, let's go into subnets. Okay, let's create two subnets for us. One in the private subnet, the other one is public subnet. So Bala public subnet, and it's going to be under Bala's VPC. Availability zone, let me put in the first availability zone, US East 1A. Then over here the subnet mask could the IP range could be 10.0.1.0 /24. Let me click on create. By default, all these subnets will go and reside in the default route tables. I'll show you that. Okay, let me create one more subnet right now and name this as Bala private subnet, and this is going to be in a different subnet of 1B. So this would be 10.0.11.0 /24. So just like in our diagram, this is what we are trying to accomplish here, right? 10.0.11.24. That's still creating, and it has created us a couple of, yeah, it has created a couple of subnets. So if you see the private subnet, right, and let's click on route. So by default it would attach to the default route table. So if I were to go inside the route table, I'll show you that. So you see this is the default route which got created. This is the default route which got created because of me just logging into AWS, right? When we create our user account, that's when this VPC would get created. But when I created my own VPC, this particular route table got created. So let's go on to security groups and work ourselves up now. So let's also go back to dashboard once before we go there. So the moment we created the second VPC, right, it created by default one route table, additional route table, one additional security group, two subnets which we created right now, and one additional network group, network ACL list. So let's go down to security group and start creating security group and name this as Bala SG uh, security group. So allow SSH and HTTP. Oh, we may also want to allow ICMP, SSH, and HTTP, and we are going to put it under this particular VPC, right? And say yes, create. So once created, we need to create all the ports which are going to be allowed. If I click on that, you would see what are the inbound rules going to be. We would say, we click on edit and say port range of 22 from o.o.o.o /o. Let me copy this because I would be using this quite a lot of times. Then another rule, I would say port inbound port 80 is also going to be allowed. Then let me add one more. It's not going to be TCP, it's going to be ICMP, and I would say any source anywhere and click on save. Alright, now that's taken care of. Let's go into NACL. In this NACL, this is the NACL which got created by default. If you see the inbound rules, everything would be allowed by default, and outbound rules, everything would be allowed by default. But that's not what we want. So let's try to constrict this further. Let's create a NACL. Name tag is going to be Bala NaCl. It's not sodium chloride. It's network access control list, and it's going to fall under the same VPC, which is Bala VPC. Now that's created. It doesn't have any subnets associated with it. If you were to see this, right? So let's go ahead and create inbound rules. Right, by default, when we create an ACL, everything is denied by default. But a default NACL which gets created allows everything. But if we create one, see this. This is no. This is not a default VPC. Sorry, NACL. So this would block everything by default, and we need to go ahead and say specifically allow these things. So I'm going to add one rule, and these rules go in multiples of 100 so that we can add one rule on top if required. So let's allow SSH from anywhere, add another rule, say 200. So this is going to be HTTP from anywhere. Let's add another rule, 300. So here I would say this is for that return traffic. Remember 102.4.265,535 ports from anywhere. That is when my machine on the internal network tries to access google.com or tries to get an update. The return traffic should be allowed, right? So that's where this particular thing comes up. So when it goes out, it picks up the outbound rule and it goes out, whereas when it comes back in, it will use this particular rule to get inside. So now that's done. Now let's add one more and say this is 400. We are going to allow ICMP for troubleshooting purpose, right? Because without that, troubleshooting becomes a bit of a hassle. So and save this. So now I have created all inbound rules. uh, so now I'm going to create an outbound rule. Edit. I can say add a rule. I would say 100. uh, Again I would say I can create SSH like this, which is easier. So if I want my inside machine to go out to an SSH server which is existing outside, that's how I would go out. And port 80, add another 300. This would be HTTPS. Add another. So let me give access for ICMP as well over here, and click on would I require for outbound rules, right? Yeah, I would definitely require one more. I'll tell you what that all ports is for. 500. So this port will be 1024 to 65,535. So do you know why I kept this particular port for? Let me click on save. So that particular port is going to catch this scenario of say I have a VM here on which SSH is enabled. So from the internet, when I try SSHing in, the destination port is going to be 22, so that will fall under inbound rule, right? So this particular thing would match here and go here, but my SSH client would have some ephemeral port open, right? The reply traffic from here would have to match something which is the ephemeral port. That's what I have currently enabled there, ephemeral port. Okay, now let's go to subnet association. Click on edit, and we want to pull up all the both the subnets which we created as part of this particular NACL. So now that we have created that, wonderful. Now let's go back to internet gateway. Okay, and let's create an internet gateway. So this is going to be bala igw internet gateway. Say yes, create. And as we learned, one internet gateway, so the currently this particular internet gateway is detached. You can attach it only to one internet gateway. As soon as I click on this attach to VPC, it by default populated that I have only one VPC where I could attach it to. So yes, attach. So now that it is attached, right? If we go back to our diagram, we have attached the internet gateway to the VPC. We have just now created an ACL. We have also created a security group. Route table is the only thing which is pending. We have also created subnets, right? So let's go back to our route table. So this is where we are going to tie things together. Let's create a route table in the first place. Okay, and call this as Pala route. Click yes, create. So now that we have created the route table, click on routes and say click on edit. Okay, so add another route. So this route is for default route to go out to all the other subnets inside that VPC. Now I would say if the destination is this, okay, you have to use internet gateway. I just clicked there, it popped up internet gateway to go out to the internet. Okay, so what I have in effect right now done is created a route table of 0.0.0.0 and said that internet gateway, that's it. But I haven't associated with it with a subnet yet. So which I'm going to do right now under the subnet association tab. Right, click edit here, and I want only my public subnet to be able to go out to the internet. I click on that and say save. As soon as I save, you will see that one subnet becomes populated here. It's populated with one subnet. Perfect. Wonderful. So now that's taken care of. Let's see the NACL. NACL also does the same thing, right? Like when I populated with two subnets, it would pull those two subnets from the default subnet, default NACL, over to the NACL which we created. Now that we have done all the things over here, let's middle click on this go over to the next tab, I have to click on EC2. Now let's start populating missions. Instances, launch instance, right? That's what we want. So I'm going to choose Ubuntu. Why always select an Amazon AMI, right? So Ubuntu, that's going to fall under the free tier, fine. So one instance, which VPC, we are going to make it go under Bala VPC, and the subnet it's going to be public subnet initially. Then should we auto assign a public IP? We say yes, enable it. That's it for this. Click on next. Next, add tags. Security group. We are going to use the existing security group which we already created, which is this one, which allows port 80, SSH, and ICMP. Review and launch. And let's click on launch. Uh, I would say that I already have access to my. Let's go over and pick up terminal. CD downloads. Ah, fat finger. Perfect. I do have that particular VPC key, so I say yes, I acknowledge and launch that instance. Because what's the point in saying yes, I have it and finally remember that I have deleted it, right? So we can go ahead and click on view instances. So in the time which it takes for it to boot up this one, let's launch another instance and put it inside the uh, private subnet, right? One more subnet which we have to show that. So configure instance. So this is going to not default subnet. It's going to be under Bala's VPC, and private subnet is where I want this to be. We don't want public IP because we don't want anyone to reach out to it. So add storage. Oh, that's looking good. That's looking good. Configure security group. We are going to use the same security group as before, or we could create another security group which allows only port 3306, because we would usually run a backend database in our private subnet, right? But for the sake of it, I'm just going to select this for right now. Click on review and launch, and click on launch. So Bala VPC, and I say I acknowledge. Click on launch instances. So view instances right now. Uh, so it's doing status check. So what the status check is like, if you go underneath the status check, we can also do this, right? So this is going to be my public VM, and that's going to be my. So it's easier to understand, right? So let's click this status check. There are two status checks which Amazon does. First is the system status check. So these status check monitor AWS systems required to use this instance and ensure that they are functioning properly. So if the system which supports the instance works, then it passes one system check. Okay, if something were to go wrong here, we'll not be able to do anything. This particular this is instance status check. So what happens is Amazon will try to send a packet to this instance, and if this instance were to reply back, then they know that this instance is working fine. So that's when you find status check 2 of 2 ready. If that is the case, then we can go ahead and log in. If not, we wouldn't be able to log in still. So while this is booting, we can also go to actions and say get logs, get system logs, right? So we can see the boot logs actually. Let me refresh it and try to bring that up. For some reason, I'm not able to see it. So usually this thing populates all our logs, how the machine is performing. So what I'm going to do is I'm going to pause the video. Once these two missions are up and running, I'm going to, yeah, so you see the 2 of 2 checks passed, right? So let's try seeing if we can get the system logs now. Usually it comes up, but today it doesn't. Okay, anyway, let's SSH to this public IP address, and let me show you that we are able to reach out to the internet. That's one, right? I want to do this. Will this work? Open terminal. Perfect. So I needed the second terminal because I want to log into the next mission, right? So if I were to cat this one, because I need that SSH. So since this is an Ubuntu mission, I need to type in ubu. Let me press enter and start, because SSH ubuntu at that particular IP address. Oh, there's a space there. Hyphen I. So that's what I'm going to use. So in the meanwhile, let me copy this, because once logged in, I need to paste this somewhere. I say yes. Okay, I have logged in now, right? So what I'll do is I'll just try to vim key.txt, insert, paste that key, escape, colon, write and quit. So for insert, what I did is I just pressed the I button on the keyboard. So write and quit, ls minus ltrh. So the permissions are really bad. So I'm going to set a more restrictive permission, ls minus ltrh. Now I see 600 permission getting applied here. Now that I'm inside, right? The other mission also passed system status check 2 of 2. Let's become sudo su and do an apt hyphen get update. So you see that my mission is able to go out to internet and pull down um, the repository updates. Then we are going to do upgrade upgrade. So this would go ahead and fetch around like 37 MB, which I'm currently not going to do. All right, so let's try SSHing into this box as well. All I wanted to do is just copy paste it. It's not going to be that easy. Okay, fine. SSH ubuntu at 54.236.243.31. Okay, hyphen I, and that's the key which I'm going to use, and I would log in. So over here, right, this is the public machine. So if I were to do wget google.com, okay, before I press enter here, I would want to SSH into the private machine as well. So for that, I'm going to click on this private machine, and if you see, it doesn't have a public IP address. It has only a private IP address of 10.0.11.192. So let's get that one up as well. So I'm going to SSH into 10.0.11.192 hyphen I, and with that key, right? And I would say yes. And if you see, I didn't specify the username while I tried SSHing, right? That is because it would pick the default username of Ubuntu, whatever user I'm trying to SSH as. Whatever username I have logged in as, that's the username it would try to SSH over there as well. So now that's taken care of, right? Let me become, it's not required. So wget google.com. So this is gonna fail because this is on the private subnet. This is on the public subnet. I hit enter. You see it got connected to Google and it pulled down that particular file. So if you want more clarification, right, what we can do is mtr google.com. mtr is nothing but a trace route kind of a program, but it's much better. So mtr google.com, and I press enter. Here you see the trace which it took to reach out to google.com, and it continuously keeps sending packets and tries to see if the routes were to change and stuff like that. So this would help, my trace route would help in certain aspects. So now that we have learned this, that's almost about it, folks, with respect to VPC. Next section, we will try to cover how we can create NAT instance or a NAT gateway to allow this machine to go out to internet. So in this machine, right, sudo su, and if I were to do apt get update, this isn't going to go out. Though it is able to resolve the IP, it wouldn't be able to go out. All right. So thanks a lot for watching this video. If you have any queries, please feel free to comment below this video, and feel free to subscribe to my channel and hit on the bell icon so that you would get future video notification right to your uh, YouTube channels, YouTube apps. Bye bye.